Here's Graham Turner's presentation.
I'm going to briefly introduce or talk a little bit about the modelling platform, that is the Australian Stocks and Flows Framework, or ASIF, and then that'll lead us into basically two sets of simulations. One where we establish sort of business as usual background scenarios, and then one where I was interested in looking at what is necessary for a sustainable economy, and that turns out to be very pertinent to a steady state economy. So ASIF is a model of the physical activity across the whole of the economy and environment in Australia. In the diagram here, Australia is represented by the large green box, and you can see that things enter in, people and trade in, and similarly things can be exported out, or people can leave the country. And then within the Australian economy and environment, if we start down the bottom, we see that we would be extracting things from the natural environment, and then as we move upwards through the diagram, we make transformations of those using energy to progressively make more evolved goods and eventually services for the population. And note that the population provides a labour force, of course, for that economy. And in our account, we have stocks of things like vehicles, buildings, industrial capital, land, for example, and then of course the flows that occur in and out of, so to speak, those stocks. Taking in some detail an account of the actual physical processes, so that when you boil this down, it's essentially a mass and energy conservation accounting system. But if this particular model doesn't operate like many people would expect, particularly economists might expect, it's sort of kind of hitting the button and letting it see how it runs, because the economic or social responses to some of the conditions aren't built into the model. So instead, we basically operated in what the software designers call the design approach. And so I can kind of illustrate this in the diagram here, where a population creates a demand for consumption and goods and so on, and that can be traced down through the transformation processes in the economy. Separately, we might set what are the supply conditions from primary industry, and you can get a mismatch or a tension between those, and you can get tensions in the environmental compartments as well. So it's actually possible, for example, to have negative water volume as a tension or mismatch between demand and supply, and that then needs to be solved by the operator of the model. And another similar familiar tension would be unemployment, and that also turns out to be an important part of the scenarios that I'll illustrate shortly. Of course, standard economists would be expecting prices to regulate the functioning of the economy so those tensions. But we basically argue that prices are really relevant in a condition where you've got marginal change, and then the past behaviour is a valid indication of what happens in the future. So that's kind of, I would say, the domain of standard economics. And in any case, even by taking some rough projections forward, ASIF results are still not going to be very far off in this marginal case. perhaps, and that might be akin to using flying on autopilot, if you like, in good conditions. But perhaps the more interesting case is when there are non-marginal changes such as a substantial resource issue, classic being peak oil. In this case, past behaviour isn't a good indicator of what might happen. In fact, just ask yourself the question, who would know what the price of oil will be in a year's time, 5 years' time, 30 years' time? So it's in this mode that ASIF's key role is to explore what the physical options are that are available to us. And then that can go to informing economic modelling or policy making. And so really this is a case of avoiding flying, depending totally on the autopilot, where we really might need the intervention of the pilot to avoid the crash. Now, I just want to illustrate that ASIF has been calibrated with many decades of historical data. As it turns out, in what I'm going to show you, we'll just do graphs of the future scenarios, and in the upper right-hand graph sort of illustrates a set of alternative scenarios comparison. And there is some spatial detail in ASIF, and that is much greater now in a new, far more detailed version that is basically up and running now. But the presentation today uses the sort of older version. So if we now move into creating our background business as usual scenario, and this was based on some work looking into the effect of population on environmental indicators. We know basically Australia's population is likely to grow, but it could be stabilised or reduced. And I've taken some of the parameters of the recent ABS population series and reproduced them in ASIF, and you see these in the graph on the right. So we're going from 2010, 5 decades out to 2060. And you can see the three typical scenarios talk about resulting 40 million, 34 million and 29 million, in 2050. But there was a scenario, the D series, that had population stabilising or even falling slightly to 21 million by the middle of the century. On top of those, some of the other more detailed background settings was an assumption that labour productivity would continue to increase at 1% per annum, and also picking up on some general policy statements and expectations from research, gains in efficiency of energy use and material use by 20% by 2030. And just to illustrate how this plays out in over the whole economy in ASIF is a graph showing for those different population scenarios, the A to D series, the greenhouse gas intensity, kilograms of carbon dioxide per dollar of GDP over those 5 decades. And you can see that there's there is indeed a fall in that intensity. There's a feedback to increase consumption levels and hence to lead to more industrial activity and increase employment and balance unemployment rate. And likewise, something similar happens if the trade surplus or debt is getting too far away from the target, then the amount of imports or the amount of industrial activity and primary production and so on is changed in order to stabilise these. So those are the key conditions for the background scenario, and now we want to take a look at what leads to. And here we see greenhouse gas emissions over these 5 decades of the simulation for those 4 different population scenarios under the conditions I just described. And you can see that, not surprisingly, the higher population has a growing greenhouse gas emissions. But even the stable population scenario only has sort of a relatively minor reduction of greenhouse gases. And similarly, on the energy security side, we look at oil imports necessary to keep the economy running. And we see that for all scenarios, the large jump over the coming decades. Again, things are easier for a small population to solve. I think another indicator is water use for those 4 different populations, and a similar story that the higher population leads to increased water use. And in fact, in this scenario, the urban use actually begins to overtake rural use. And essentially, what this means, for example, in the Murray-Darling Basin, is a graph sort of showing actually in the first half of its reproduction of historical flows out of the Murray River. And you can see a distinct drop in the last couple of decades. And then the scenarios also incorporate what might be now a somewhat outdated A1FI climate scenario. And essentially, the Murray River runs dry on average, not just 1 year, but on average, by the middle of the century for all the population scenarios. So again, larger population grows. And then finally, just on the economic side, what we calculate here using a GDP proxy, which is based on the wages earned by the labour force and the profits won by the physical capital in stocks and flows framework. So GDP on an index of 100 here at the beginning increases under all population scenarios, and it's obviously bigger in total for the larger population. But per capita wise, there's really no difference between those different populations. So in that sense, it doesn't make sense to have a larger population when it has a larger environmental impact. So now I was asking the question, what would be necessary to turn some of those curves around in the environmental domain to achieve sustainability? And of course there's many things that are raised, population being one, the use of technology another, and our lifestyle of consumption yet another. So I try to encompass these different factors. So we start off with efficiency in energy use and in material. Then I've essentially doubled efficiency in energy and materials across all sectors of the economy simultaneously. Also, in terms of producing electricity, instead of being largely fossil fuel based, I've switched it over to largely renewable with a bit of backup from gas. Now there are some more sophisticated, very detailed simulations we've done in combination with Mark Diesendorf and colleagues, and this gives a good feeling of what's possible. And then on the population side, here I've basically assumed let's move towards a stabilised population, about 21 million, and that involves halving the birth rate and having a zero net immigration. So of course people will still leave Australia, and so there can be a matching number of people that will in. but still very demanding sort of target to achieve. And on the lifestyle side of things, in terms of consumption, again, I've aimed to halve that in terms of all of the goods acquired, house size, and personal and business travel. If that's all we did, there would be a major problem, because there would be a large proportion, up to half essentially, of the population unemployed by about the middle of the century. And so one key factor is to consider the work-life balance, and here I've aggressively moved us over to actually a 3-day working week by the middle of the century. Of course, this means you would have 4 days a week for leisure in quotes, because naturally you wouldn't have income available to you buy as many things, so you might have to spend a bit more time with family and friends, or reading or gardening or whatever other sort of productive activities around personal space. So what that means in terms of our outcomes in the simulation, and employing, basically I introduced those strategies one after another, and hence there are multiple curves on these graphs. But the key point to notice is when at the top of the graphs, the orange and brown curve is one of the earlier business as usual scenarios based on the median population of Series B. And this is looking at greenhouse gas emissions at the time, and then implementing these changes and then adding all of them in together gives us the green light. And you can see that essentially we do basically achieve the sort of suggested targets, 60 to 90% reductions by the middle of the century. On our energy security, that also is improved from that business as usual to having all of the strategies in place, although we don't do away with our reliance on foreign oil, whatever price might be in the future. But of course we could introduce more other changes to, say, switch across to a different transport fleets based on, say, electricity or hydrogen and so on. All in that again from the business as usual to the green line with all of the strategies. And what that means for the Murray River is that the flow can almost be stabilised, but of course there's still, over this time frame, an effect of climate change from all previous emissions, basically. So, but nevertheless, the combined full set of strategies does see Murray River, on average, stay flowing well into the century. Does this mean living in a cave, however? Not necessarily. So, indeed, here I show the GDP and GDP per capita graphs again. You see the growing total GDP of the background business as usual, but then the combined strategy has the effect of essentially creating a steady state economy, of flatlining GDP. And because population is stabilised, this means that GDP per capita is also flatlined. So on average our wealth is maintained. So we should note that part of that GDP is not just going to individuals, it's also going into investment in new capital that change over to renewables and more efficient capital and so on. So really this brings me to the end, and just to summarise very briefly, a sustainable economy as I've implemented here in this biophysical simulation leads to a steady state economy. I actually wasn't starting out to try and create a steady state economy. I was looking at what's necessary to achieve environmentally sustainable economy, but they turn out to be largely one and the same in this simulation. And that was achieved by doing, obviously, immense changes. And they're sweeping because they're applied across the whole economy simultaneously. And just summarising here, what's necessary is to have a no-growth population, and that's quite an immense challenge to achieve that in itself. Then there's all of the technological changeover across all of the capital and so on that's already in place. And then, of course, to actually change our lifestyle, and the key point here being to reduce the working week, and that would, of course, naturally lead to reduced consumption. And there would also be questions about how could this be managed when people have so much debt, and that's a legitimate question. It's in the rather hard basket. So, with all of that summary, I'd like to just also pose a very brief question. How likely is it that we could achieve all of these changes? And my judgment would be that any one of these three main strategies is rather unlikely, that the whole suite of them is therefore extremely unlikely. And but of course we don't lose hope, and we still try to attempt to get the change. And I guess that then begs the question of the other presenters and colleagues in the conference about how could we encourage and implement such a change. Well, I hope that's been informative, and unfortunately I can't take questions, clearly not being there, but I'd be very happy to be contacted under the details here for any follow-up. Thank you very much.